So in this video we're going to look at the 7 quality tools. You are familiar with some of these, especially the Pareto analysis, and you might have done them in other classes also, but I'm going to go through them. The first one is a check sheet, the second is a histogram, Pareto chart, cause and effect diagram, defect concentration, scatter chart diagram, and control chart, or sometimes referred to as run charts. I'm going to go through each of these, except for I'm not going to cover control charts in this video because we'll be looking at it in other videos. So check sheet, there's actually 5 different types of check sheets, and I'm going to go through each of them. This is referred to as a character classification checklist, and one thing about this is, the thing about this check sheet is that it has on it different causes or different classifications of defects that you're going to be looking at. So in this case it's a supplied parts are rusted, misaligned weld, improper test procedures, you can see that. And then also the other thing that's on this particular check sheet that can be on other check sheets also is that there's some sort of time oriented. So to see if there is any pattern associated with time, and that's what check sheets are used for, is to identify patterns and also to just simply record things onto a check sheet. The next one is a location check sheet, and this is where you look at the physical location of the trait and indicated on a part or item being evaluated. So in this case there's a picture of a door, a car door, and it shows the different types of defects and where they are on the door. So you can see if there's some things that are in certain parts of the door. This is also very similar to a concentration chart that's used, these check sheets. The next one is frequency. So this is similar to that other one there, but the idea is that you actually are really looking for which is the most, the presence of a particular trait, and looking for the occurrences of that trait on a part. So we look for quite a bit associated just with the frequency of it. Another way to do it is some sort of measurement scale. Also, this also creates a histogram with this particular check sheet. So you can see that you're actually measuring here film thickness, and it's divided into intervals so that you can then indicate how often a particular attribute is occurring, that's something you can measure. This is a measurement scale check sheet. And then one that's sometimes included as a check sheet, but also gets, it's also in itself something different, which is a checklist. And it's the items that are to be performed on a task in a particular list, a list of, so you can actually check it off. It's a checklist. And this is one for flight, for airplane flying. Now the next thing I'm going to cover is Pareto chart, and I know that you made a Pareto chart in IME 223, and you're probably familiar with it. The person who created a Pareto chart was Vilfredo Pareto, and he did some studies in the 1700s on countries and the distribution of wealth, and he argued that all countries and all times the distribution of income and wealth is highly skewed, with a few holding most of the wealth. And later on this was translated into an 80-20 rule, where roughly 80% of the effects come from 20% of the causes. And in the realm of wealth concentration, this is 80% of the wealth is concentrated in 20% of the people. And that's really the basis of Pareto charts. And up there you can see in the chart, you can actually see a Pareto chart that was made in Minitab. You can also make these in Excel. But what it does is it orders the causes of things from most to least, and then you can make judgments about, if we just are concerned about the top 80%, how many items would we have to do. So you can see here, if we read this chart, this top 80%, it seems that if we could just work on these, then we would when we would take care of 80% of the problems. And this is just another chart of this, where you have these definite causes of customer complaints, and there's a significant few and an insignificant many, and it occurs, theoretically it occurs at that 80% line, and that's the concept of Pareto. The next is a cause and effect diagram. So cause and effects analysis was devised by Ishikawa, and it was a way of really using mind mapping and brainstorming together to try to get an organized way. Sometimes people call it a fishbone diagram too. And the first thing you do, the order that you do things, is you first identify the problem. And I have solution independent there. What that means is you need to say, this is the problem, this is what's going on, and have no relationship to what the solution for that might be. You need to get a team together, and then you work out the major categories of the particular problem. And then you identify possible causes within each of those categories. And this is an example of a cause and effect diagram. And you can see the category, the problem they're dealing with is here. It's a variation in resin output. And the reason it's sometimes referred to as a fishbone is that these arrows or the lines coming off of it look a little bit like a fishbone. And then there's these four, in this case they have four major categories: machines, people, materials, or methods. And then within each of these, what they've done is they tried to brainstorm, okay, if it was the machine that was causing this variation, what could that have been? So dirty, viscosity, proper viscosity for the machine, anything associated with it. And then having to do with people, maybe people are handling it wrong, it's an improper setting. What are the reasons that it might be caused by people? And then materials, and then methods. So it really has a way of really laying out all of these causes, and then you might want to then say, well, which is, maybe use Pareto analysis to try to figure out which is the one we should be looking at the most, or that's causing the most trouble. But it's a way of getting it all out in one place. The next is a defect concentration. Again, this is very similar to the location check sheet, where you draw a picture of the part and then you indicate on the part with these, in this case they use these little symbols associated with where these defects are occurring. And that might give you a clue to where you should be concentrating your efforts. Another thing is a scatter diagram. And in a scatter diagram, what you're trying to do is relate variables that you could later do some analysis about, is there some sort of cause and effect associated with it. You can see here we have patient falls versus staff vacancies. So somehow or other they wanted to know if there was a relationship between a patient falling and not enough people. So they did fit a line, and they determined an R square, and you can see that R square is not very high. It doesn't. We don't have any statistics on here, but it's not very high. It's pretty close to zero. And then the last one is control charts. And control charts are something we're going to spend quite a bit of time, because there's quite a few varieties of control charts. But this is one this is just an example of one where we have samples over time in the x-axis, and then we have bands around an upper control limit and a lower control limit, and then an average that we're shooting for. And then in each sample we'll chart it, and if it goes beyond the upper control limit, we might react to it, or there's a lot of other things we might show if there's a trend associated with it. But we'll learn about how to use control charts quite well. All right, that's it. The person who created a Pareto chart is Vilfredo Pareto, and he argued that all countries and times, the person who created
Are you trying to make a joke?
No. The person who created a Pareto diagram was this guy Vilfredo Pareto, and he did some economic studies. Oh shit! Stop!
His name's Alfredo Pareto.
It's Bill.
Oh, his stomach.
Vilfredo Pareto.
Oh.
Okay. Okay. The person who created a Pareto chart. Oh man. Could you leave?
Yeah.